Okay, this is section 4-6, similarity and transformations. As you know, I'm out of town, so here is the video. So this is for the sub. You may have to start and stop this so they can keep up with the notes, because I'm not going to pause. It takes way too long if I just pause. So I pause at this screen so they can write the notes down, and then similarly for the other slides as well. Okay, so you guys should have written these down, and now we're on page 119 of your notebooks or your journals. So similarity transformation is a dilation or a combination of dilations and rigid motions. So we're going to either shrink and enlarge it in addition to either rotating it, translating it, or reflecting it. And two figures are similar if and only if, remember that is not misspelled, there is a similarity transformation that maps one of the figures onto the other. So for congruent, remember they have to have the same shape but the same size also. For similarity, they have the same shape but different sizes. So for similarity, it's same shape, different sizes. Do that one more time. Similarity is same shape, different sizes. Okay, so our learning target is that I can identify the effects of rigid motions on figures in the coordinate plane and space as a translation, reflection, rotation, dilation, or composition of transformations. So in exercise 1-3, we have to graph this polynomial with the given vertices and its image after the similarity transformation. So I would pause here so the students can graph the original quadrilateral, the four-sided figure that we're going to graph. And then we're going to do a translation and dilation. So I'm going to go ahead and graph it. So A is a 0.36. And B is a 0.25. Yikes, doesn't like B. Alright, so B is 2.5 and C is 4.3, 4.3. And D is 5.5. And we're going to connect the dots. And then we're just going to double check that I graphed these in the correct spot. So A is a 0.36, so I went right 3, up 6, 1, 2, 3, 4, 5, 6, yep. B is a 0.25, so over 2, up 5, 1, 2, 3, 4, 5. C is over 4, up 3, 1, 2, 3, 4, 1, 2, 3. And D is over 5, up 5, so over 5, 1, 2, 3, 4, 5, up 5. Okay, so now we have to translate it. So remember x minus 5, y minus 3, x minus 5 means left 5, and y minus 3 is down 3. And I'm going to put in some points, so let's go ahead and rewrite these. A is 3.6, B is 2.5, C is 4.3, and D is 5.5. Okay, so first I'm going to do the translation. So I'm going to go left 5 and down 3. So let me get a new pen, a new color. And I'm going to go left 5 and down 3. So A is going to go left 5. So 1, 2, 3, 4, 5, and down 3. 1, 2, 3. This is going to be my new point, A prime. Okay, B is going to be left 5. So 1, 2, 3, 4, 5, and down 3. 1, 2, 3. This is my new point, B prime. And C is left 5. 1, 2, 3, 4, 5, and down 3. 1, 2, 3. C prime. And D is left 5. 1, 2, 3, 4, 5, and down 3. 1, 2, 3. So here is D prime. Okay, now if I follow the translation, remember I'm replacing x with 3 and y with 6. So right here I get 3 minus 5 and 6 minus 3. So a prime should be negative 2, 3. So let's see if it is. A prime is negative 2, 3. It is. And then b should be, I'm going to replace x with 2 this time, so it's going to be 2 minus 5. So 2 minus 5. And then the y value is 5, so 5 minus 3. So b prime should be 2 minus 5, which is negative 3, and 5 minus 3, which is 2. So b prime should be negative 3, 2. And it is negative 3, 2. And the similar thing for c. c is 4, 3. So I'm going to do 4 minus 5 and 3 minus 3. So c prime should be negative 1, 0. And sure enough, it's negative 1, 0. And lastly, d is going to be 5 minus 5 and 5 minus 3. So d prime is going to be 0, 2. And sure enough, it's 0, 2. Okay, now I have to do the dilation. So the dilation is multiplying everything by 3. So, get another color, and we'll do this one in purple. Okay, so I'm going to find a double prime, I'm going to take a prime and multiply it by each coordinate by 3, because this is saying by 3. So it's going to be, a prime is negative 2, 3, so it's going to be 3 times negative 2, and then 3 times 3, because it's a point negative 2, 3. And that's going to give me negative 6, 9. B double prime is going to be 2 times negative 3, so 3 times 2, and then, sorry, wrong, so let me erase, and get the pen back. Okay, b is b prime is negative 3, 2, so it's 3 times negative 3, and then 3 times 2, and that is negative 9, 6. Okay, and then I'm running out of space. I think I can fit c double prime right here, so c double prime is 3 times negative 1, and then 3 times 0. So that would be negative 3, 0. And then finally, d double prime I can do right here, and that's going to be 3 times 0, and then 3 times 2. So that's 0, 6. So now I'm going to plot these points. So a double prime is negative 6, 9. So negative 6, 9. It's right here. And that is a double prime. And then b is negative 9, 6. So negative 9, 6 is right here. And this is b double prime. And then c double prime is negative 3, 0. So here's negative 1, negative 2, negative 3, 0 is right here. So that's c double prime. And then lastly, d double prime is 0, 6. And then I just have to connect the dots. So these two get connected. These two get connected. These two get connected. And these two get connected. So is that the same shape? It is. Is it a different size? Yes, it's bigger and it's 3 times the size. Okay, so we're going to do number 2 now. So number 2, we have RS and T. So we have to plot RS and T. So R is 12.8. So 12.8. And S is 8.0. This is R, this is S, and T is 0.4. And I'm going to connect the dots. That was pretty bad. Let's see if I can draw that better. That's good. Okay, so it's a triangle, and the first thing we have to do is the dilation. So I think I'm just not going to write RS and T down. They're already right there. But R prime is going to be 1/4 of 12 and 1/4 of 8. So 1/4 of 12 is, if I put these over 1 and I multiply across, I get 12 over 4, which is 3. And 1/4 of 8 is 8 over 4, which is 2. So 3/2. And then S prime is going to be 1/4 of 8 and 1/4 of 0. So this would be 8 over 1, so 1 times 8 is 8, and 4 times 1 is 4, 8 over 4 is 2, and 1/4 times 0 is just 0. And then T prime is going to be 1/4 of 0 and 1/4 of 4. And 1/4 of 0 is just 0, and 1/4 times 4 over 1 is 4 over 4, which is just 1. And let me get a new colored pen. So I've shrunk the triangle to 1/4 of its size. So R should be 12.8. 12.8. I'm sorry. R prime is 3.2. Sorry, 3.2. So this is R prime. And S prime is 2.0. And finally, T prime is 0.1. So it's the same shape, it's just shrunk. Now we have to reflect in the y-axis. Okay. And really, I didn't leave myself, did I? Barely enough space. There's barely enough space. It wasn't me, it was the book that made this, so not me. But again, let me highlight the y-axis. So we're reflecting over this line. Okay, and I'll do this in blue. But I want the pen. Alright, R prime is 3 to the left or right of the yellow line, so R double prime has to be 1, 2, 3 to the right or left, R double prime. And then T's on it, so T double prime is not going to move either. And then S is 2 to the right, so S prime is going to be 2 to the left. S double prime, and I'm going to connect the dots. Okay, and then I have to write these down. So R double prime is right here at -3.2, and S double prime is at -2.0, and T double prime didn't move, it's at 0.1. And again, if I'm reflecting over Y, the rule is the x value changes sign. So r prime should, instead of being positive 3, 2, should be negative 3, 2. And s prime, instead of being positive 2, 0, should be negative 2, 0. And then t, when I change the sign of 0, I just still get 0, so t double prime is 0, 1. Okay? That's using point manipulation. Alright, number 3, we have this point. There are this triangle, so we have to draw this triangle. And then we're going to rotate it 90 degrees about the origin, and then we're going to do a dilation of 2/3. Okay, so let's plot the first point. So 9, 6, 9, 6 is right there, and that is x. And then y is 3, 3. And z is negative 3, 6. And I'm going to connect the dots. So I have this triangle here. Alright, so now I'm going to rotate 90 about the origin, so let me get another color pen, and I'm going to write the rule for 90 degree. So AB, and this is 90 degrees, so, and it doesn't say clockwise or counterclockwise, but it's positive, so remember positive is counterclockwise. So we're going 90 degrees counterclockwise. So the rule is AB gets mapped to negative BA. AB gets mapped to negative BA. So we'll do this in red. So they're going to trade places, and the second value, which is the original y value, is going to change sign. So I'm going to underline those so I remember that's the one that changes sign. But they're also going to flip. So that means that x prime has to be what? Well, negative 6, because that has to change signs, and then 9. And y prime has to be, this one changes signs, so negative 3, and then 3. And z prime has to be negative 6, and then negative 3. Okay, so let's plot that. So negative 6, 9 is right here. And that is x prime. And then y prime is negative 3, 3. So negative 3, 3 is y prime. And z is negative 6, negative 3. Uh-oh. Really? I hate this. Let me make sure I didn't make a mistake. That's the one that changes signs. So negative 6, negative 3. Yep. Alright, well, the book did not provide a big enough piece of paper, so we have to go one down. This is 1, 2, and this would be negative 3. So right there is z prime. Okay, so we rotated it at 90 degrees. And if you like, you could, I don't know, draw this out a little. If you want to have this extra line thing here. Okay. There. Need an extra little column for the z prime. Okay. So now we have to dilate 2/3. So x double prime, let me get a new color. so x double prime would be 2/3, and then the x value, which was -6 over 1, and 2/3 times the y value, which is 9 over 1. So that looks like -12 over 3, which is -4, and 18, 2 times 9 is 18 over 3, which is 6. So x double prime is -4, 6. Y double prime, same thing, 2/3, and then the y value is -3 over 1, and then 2/3 times the x value, which is 3 over 1. And that gives me -6 over 3, which is -2, and 6 over 3, which is 2. And then lastly, z double prime is 2/3 times -6 over 1, and 2/3 times -3 over 1. And that looks to be -12 over 3, which is -4, and -6 over 3, which is -2. So it looks like -4, 6, right there, is x double prime, and y double prime is -2, 2, and z double prime is -4 or -2. Okay, something didn't happen right here. Oh, that's what went wrong. I put that in the wrong spot. Erase. You probably caught my mistake. It's -4, -2. -4, -2. 1, 2. So right here is z double prime. And I'm going to connect the dots. And that line looks pretty bad, so let's erase it and see if I can draw a better line. Yeah, definitely better. Alright, so it's the same shape as the red one, just a different size. And the red one was the blue one translated 90 degrees. So there we go. Alright, now this time they give us the two figures and we have to figure out the what happened. So for me, I always think it's easier to shrink and then move. So we're going to look for the shrink size first. So we're going to compare. We're going to look at a side. And when we're looking at a side, we can choose any side we want, but either horizontal or vertical side is better than a slanted side. So I'm not going to pick ML. So I'm going to look at NM. So I'm going to look at how long NM is. NM is how many units long? 2. And N prime, M prime is how many units long? And that's 1. Okay, so remember the dilation rule, and we learned this back when we taught dilations, is it's the ratio is prime over non-prime. Non over non-prime, prime over non-prime. So the non-prime measurement here is 1, and the prime measurement is 1, and the non-prime is 2. So that means my scale factor, my ratio, is 1/2. So that means I had a dilation where xy gets mapped to 1/2 x and 1/2 y. Okay, I've used up a whole lot of space with that, but here, I guess we'll go here, and I'll go ahead and color. and maybe right here we'll write the things. So n is the point 0, 1, 2, 3, 4, 5, 6. And m is the point 0, 1, 2, 3, 4. And L is the point 6, 6. So 6 and 1, 2, 3, 4, 5, 6. Yeah, 6, 6. Okay, so that means if I shrink it first, this n double prime, we don't want to call it prime because this is already prime. So this n double prime is going to be 1/2, 0, 1/2, 6. So 1/2 of 0 is 0 and 1/2 of 6 is 3. So n double prime is 0, 3. That's n double prime. And then m double prime is the same thing. It's going to be 1/2 of 0 and 1/2 of 4. So 1/2 of 0 is 0 and 1/2 of 4 is 2. So 0, 2. And then finally L double prime is going to be 1/2 of 6 and 1/2 of 6. So 1/2 of 6 is 3, 3. So 3. Oh my goodness, and I wrote this in the wrong spot, didn't I? Okay, let's fix this. Okay, so I know you probably caught my mistake right away, but you know, I'm a little slow. Let me get my eraser. So I plotted these points incorrectly. Whoops, go back. So I need my eraser. So let's try again. Okay, so this was 0, 3, so 0, 3, not 0, 2. So this is n double prime. And this is 0, 2, which is n double prime. And then finally, this was L double prime, which is 3, 3. So 3, and then 1, 2, 3. And I'm going to connect the dots. Okay, let's erase that. It's messy. So there, there, and there. Okay, now how do we get it from here to here? Well, it looks like M has to go right. Let's get another color. We'll do this in blue. It has to go right. 1, 2, 3, 4. So right 4 and down 1. So it's a translation, and XY gets mapped to right 4 is X plus 4 and down 1 is Y minus 1. So that's how I'm going to get from here to here. So notice if I go right 4 and down 1, I end up there at n prime. L right 4, 1, 2, 3, 4, and down 1, I'm at L double prime, or at L prime. And if I go right 4, 1, 2, 3, 4, and down 1, I'm at M prime. Okay? So this is the answer, dilation of a half and a translation of X plus 4, Y minus 1. Alright, and number 6. So this one looks like a reflection, and a dilation. So if you notice, this is flipped over. So we're going to reflect this over what axis? Let me get my highlighter. We're going to reflect over this axis, the y-axis, right? And if I reflect over the y-axis, this is C is 1 away, so C double prime is going to be 1 away on the other side. A is 3 away, 1, 2, 3. And A double prime is going to be 1, 2, 3 on the other side. And I'm calling these double prime again because these are already primes. And then B double prime is 3 away, so 3 on this side. So now I have the reflection, so now it's shaped the right way. Now I just have to look at the side. So I'm going to look at a flat side. So I'm going to look at AB, and AB is 2 units long, and A prime, B prime is 1, 2, 3, 4 units long. So it looks like it's a scale factor of 2, because remember it's the prime over the non-prime. So 4 over 2 is 2. Remember, it's the prime over non. So 4 over 2 is the dilation. So it looks like we had a reflection in the y-axis, and then we're saying it's a dilation where xy gets mapped to 2x, 2y. And let's just double check that that works. So let's get my pen going, and we're going to write some things down in red. It looks like A double prime was the point 3, 3. And B double prime was the point 3, 1. And C double prime is the point 1, 1. 1, 1. So if I multiply each of those by 2, I get 2 times 3 and 2 times 3, which is going to be A prime, which is 6, 6. So let's see if A prime is at 6, 6. And it is. Here's 6. 1, 2, 3, 4, 5, 6. So 6, 6 for A prime. B prime is going to be 2 times 3 and 2 times 1. So that's going to be 6, 2. And if you look, B prime is definitely at 6, 2. And then C prime is going to be 2 times 1 and 2 times 1. So C double prime, or C prime, is going to be 2, 2. And if you look, it is. So that worked. Okay? Alright, so now that you're done with the notes, you can do the rest of what I have left for you.